Welcome back to Aurora Tech Channel. Today, I will review a large desktop CNC from NymoLabs, the NBS-6040. As the name suggests, the working area is 600 by 400 with a Z travel of 115 millimeters. This machine costs $1,800, so let's take a closer look at what we can get from it. The motion system on all axes uses linear rails and ball screws. The X-axis and dual Y-axis are protected by panels on all sides. The bed is an aluminum and MDF hybrid bed, and for the spindle, instead of a small spindle commonly seen on other machines, it comes with a custom 710-watt router, similar to the Makita router that I've used on many other CNC machines. When using a Makita router, the problem is that the collet is a 1/4 inch. I can add an 1/8 inch adapter to use other bits with a smaller shank, but this custom router uses an ER11 chuck that allows you to use all ER11 collets and common CNC bits. The power is connected to the controller box, so the spindle power can be controlled using G-code. But for the speed, you still need to use the knob to manually adjust it. The stepper motors are higher torque NEMA 23. The machine runs Gerbil firmware, and the motherboard and stepper drivers are packed inside the electronic enclosure. There's a 2.8-inch touchscreen for you to work completely offline. Just generate G-code and it can run without you having to connect the USB cable to the computer and running another G-code sender software. For other accessories, it comes with some basic bits, a Z-probe for tool height setting, limit switches on all axes, some extension ports for future upgrades like the MPG handwheel, air assist, the laser module, a 4th axis, and lighting. It also comes with 4 spring-loaded clamps for fixing the workpiece. I would like to thank NymoLabs for sending us this machine and for sponsoring today's video. With that, let's get started. This huge box weighs 130 pounds, so there's no way we can lift it and put it on the table. Everything is well protected by tight-fit laser-cut foam. This thing is massive, but it seems the parts are pretty simple. We have the aluminum and MDF hybrid table, the X and Z axis, the dual Y axis, the router-style spindle, the controller box with a touchscreen, some cables, tools, and 4 clamps to hold the workpiece. First, we will put the aluminum bed together and put the MDF boards to form this hybrid bed. Put one modular Y-axis on each side, and then we can put the heaviest part, the X and Z axis, on the Y-axis. After that, install the spindle and finally connect some cables. Now, we can turn on the machine. The touchscreen looks better than most other budget CNC controllers, and it has quite a lot of options. First, we will home the machine. It has the option to set the seek way, which is the fast travel speed. The slower rate is the movement after the limit switch is first triggered using the fast travel speed. It will use a slower speed to find the exact 0 position. The pull-off distance is how far it will bounce back after the limit switch is triggered to avoid the limit switches being kept pushed down. Let's jog the machine around. It seems all directions are working normally and the spindle is also responding, but we can only turn it on or off using the controller or G-code. For the speed settings, we still need to use the knob to adjust it manually just like a wood router. It seems the touchscreen has quite a lot of options. On the main screen, it shows the real-time position of the X, Y, and Z axis. Inside the Repair tab, we just tested the jog buttons and spindle on and off. On the second page, we can do a Z probe, zero the axes, and choose a file from the microSD card to start a job. Inside the settings, we can set all the parameters, which normally requires us to connect to the computer with a USB port and change using Candle or a universal G-code sender software to change these parameters, but it seems this touchscreen can almost replace the Candle software. To confirm that, I will try to do all jobs without connecting to the computer and see if this machine can work completely offline. Okay, let's load a bit, starting with one of the engraving bits that came with the machine. As it came with an ER11 chuck and collet, it's the same as how you install a bit on a small spindle. Then, I will use some leftover poplar wood and mount it using the spring-loaded clamps. Jog the machine to the starting XY position, which I normally put in the lower left corner. For the Z height, we can use the probe that came with the machine, and the height of the probe is around 12.2 millimeters. Just let the probe set the tool height automatically. Okay, now the machine is ready. Let's generate a simple G-code file from Fusion 360. I will just engrave some text and an outline at the speed of 1000 milliliters per minute with a 0.5 millimeter step down. I'm sure this machine can be much more aggressive than that, but as I just want to ensure everything is working, I will use a relatively slow speed for the first test. I will save the G-code directly to the micro SD card and use the screen to select the file, starting with the default 100% speed that follows the G-code. This is all the information you can see from the touchscreen in real time. Besides the spindle speed being manually controlled, the rest of the data is accurate. It finally took less than 5 minutes. I think this simple job can finish in 1.5 minutes, but doing 4 passes really makes the edges look cleaner. Considering the workpiece and all the text are small, the result is okay. Next, let's try some harder red oak wood. I will engrave a Gryffindor logo on it and run a contour to cut it out. The result is very clean. Then, I will switch to a 1/8 inch 2-flute flat end mill that came with the machine to run the contour. Each pass took around 25 seconds, and the job finished in around 3 minutes. The engraving is mostly clean, but it could be even better with some light sanding. The edges are cut very clean, and the back also looks fine. Then, I will try to do some acrylic engraving. I will engrave some SVG files of Spider-Man, Autobot, and Superman on a 3mm piece of acrylic. Engraving on acrylic can result in really blurry edges, so I will run 2 passes first. As expected, the blurry edges are pretty obvious, so I will do a 1mm cleanup pass. It looks better, so I think doing another cleanup pass should be fine. Each cleanup pass took 7 minutes, and the actual engraving time is around 14 minutes. So with 2 cleanup passes, the total time of this job is about 30 minutes. But as you can see, the result is really good after doing 2 extra cleanup passes. Next, I will cut a ninja star on the other end of the same piece of 3mm acrylic. It starts with the bore operation to make a hole at the center. Then it will run a contour to cut it out with 7 passes. I won't use any tabs as this acrylic should just pop out after the final pass. It normally won't damage the part, and once the final pass started, we were actually hiding 15 feet away from the machine to avoid getting attacked by the ninja star, because even if it's a toy and not sharp, it's still a ninja star, so who knows. Anyways, the job took around 3 minutes and the part is perfect, and after removing the stick at the back, it looks even nicer. As this custom router uses an ER11 chuck, I can use a larger 1/4-inch collet in a coated carbide end mill to cut 6061 aluminum. I will mark some numbers for the maximum step down of each pass, then make 6 slots from a 0.25 to a 1.5mm step down and see how far we can push this machine. As you can see, we do fewer and fewer passes, and the final one will use a maximum 1.5mm step down. Surprisingly, all of them look alright. I was expecting the maximum I can push it is about 1mm, but it seems it's still doing okay, even when cutting at a 1.5mm step down. Let's try to run the same G-code on a piece of brass. After this 1.25mm run, I will stop the machine as the brass is a bit narrower than the aluminum, and I don't want to test cutting my mini vise, even though I cut it before by accident. For the 1.5mm step down slot, I will make a longer one here. The result is similar to the aluminum. I think the machine can handle slot cuts at a maximum of a 1.5mm step down without issues. The 0.25 up to 0.75mm looks really clean. The 1.25 and 1.5mm ones are not as clean, but they're still definitely acceptable. Okay, let's talk about the pros and cons of this machine, starting with the pros. 1. The machine is heavy and weighs 130 pounds in total. The all-linear rail and ball screw motion system helps to keep the machine sturdy even when cutting metal at a pretty aggressive speed, like 300 milliliters per minute with a maximum 1.5mm step down. 2. The custom router actually solves a few problems compared to just adding a Makita router to a regular CNC. You don't have to spend another $130 to $160 to get a Makita router when it was $100 to $120 last year. This custom router power is connected to the machine, so it can start with the G-code while an added-on Makita router needs to connect to another power source and has you manually turn it on and off. And this setup is not only handy, it's also safer, as when you hit the emergency stop button, the machine and the router all stop together. It uses an ER11 chuck, so you can put different collets and use a broad range of router bits and end mills. 3. The touchscreen is super handy, and I did all the tests in this video using it. While you can still connect it to the USB port of your computer and control the machine through the virtual COM port like other machines, if you have experience with the Candle or UGB G-code sender, the virtual serial connection can be lost or get interrupted sometimes. 4. The assembly of the machine is fairly easy and straightforward. As long as you have the strength, it won't be a problem to put everything together in about 30 minutes. For us, it took a bit longer as these parts are pretty heavy. 5. Most of the small details are well designed. The hybrid aluminum and MDF bed is good, with a set of better quality clamps for you to secure your workpiece. The cable chain is pre-installed. The cables from all axes, including stepper motors and limit switches, are integrated into 2 multi-pin cables. This makes the connection cleaner, and there's not much you can do wrong. The ball screws and rails on the X and Y axis are well protected from dust and debris. All the stepper motors have a knob to turn manually, so if you need to do a little adjustment, you can manually turn it and zero the X, Y, and Z axis on the screen. Now for the cons. 1. The 2.8-inch touchscreen is too small. It came with a plastic stylus and it is functional, but even a $200 budget 3D printer comes with a 4.3-inch touchscreen. Using a 5-inch or at least a 4.3-inch touchscreen may increase the cost by just $10 or $20. 2. The screen UI can be improved. It contains a lot of information, but some buttons just aren't well designed. For example, the settings menu spans 9 pages, yet the back button is only accessible on the first page. Additionally, there are some typos on screens, like the previous button, which shows up on multiple screens. While these are not major issues, there are things that could easily be addressed with a firmware update. 3. The limit switches are very basic like the ones you see on a budget 3D printer. I think this machine also deserves better ones, which would cost just a few dollars more. 4. The X and Y axis are well protected from debris and dust, but the Z axis is not. The manufacturer could use a similar design to the X and Y axis, or at least consider adding a bellow cover like one of my huge 6090 machines. In conclusion, the build quality of this machine is good and is in line with machines like the Saint Smart Genmitsu, which I previously reviewed. Things that make this machine stand out from others are the custom router that uses an ER11 chuck, and the router power is also controlled by G-code with a touchscreen that can run completely offline. This is especially useful if you're using it to make products, as you can just store frequently used files on the machine and operate without a computer. but the drawbacks are that the brand and machine model are all new. So for now, it doesn't have that many accessories like Just Collector, for you to connect a shop vac, or a fourth axis. But based on my tests, it's a very solid machine that allows you to work with different materials like softwood, hardwood, acrylic, and soft metals at a pretty aggressive speed with good results. As a machine of this size, with all linear rails and ball screws on all axes, the hardware itself is worth the price. The cons I mentioned are not deal breakers, they're just some minor issues and small improvements that can make this machine even better. If you're interested in the NymoLabs CNC 6040, I've included the link in the description and on my website auroratechchannel.com. My website also monitors prices for over 100 popular 3D printers, laser engravers, and CNC machines, and provides detailed specs for easy comparisons. That's it for this video. If you found this video helpful, please give it a like and consider subscribing to our channel. Thank you for watching, and I will see you next time.